students. There were a couple of things from class that we did not have the chance to get to. And so I wanted to make sure to just record a couple of additional notes for you all to be ready for the Take 2 quiz on this material on Monday. The first thing that I wanted to point out on your calculator is how to check to see if your calculator is in degree mode or radian mode. So I saw a lot of mistakes on the quiz where the answers that were being gotten were just simply incorrect because the angles were given in degrees and the calculator was used in radians or vice versa. So it's just really important to match the calculator to the problem. On your calculator, there is a button here that says mode. And then you can see on the menu, and your menu might look slightly different, but there should be a place on here where you can use the arrows to choose between degrees or radians. So right now it's in degrees. Let's say I need to go to radians. I can go there and hit enter. And now you can see I'm in radian mode. Or if I'm in radians and I need to be in degrees, I can hover over degrees and hit enter. And now we can see that it's selected degrees. Okay, to get out of this menu, you can just hit your shift key and then quit, and now you are back to your operation screen. So that's just a handy tip. Make a note to yourself on your note sheet. Just a little reminder with the star and exclamation point, check to see if you are in degree or radians mode. Okay. The next thing that I wanted to go over was just a reminder on how to solve problems like number 4 on the quiz. So if you remember problem number 4 on the quiz, there was a maypole and there were children dancing around the maypoles with ribbons, and we were given the following information. We were told that the maypole itself was 25 feet high, and that the student or the child was making a 35-degree angle with the ribbon. Oops. And then the part that was requested was how far away is the child from the pole? The way that we are going to solve a problem like this is we're going to consider the triangle from the perspective of the angle. So it's like this is our theta. And we are going to label the sides of the triangle based on their relationship to the angle. So in this case, this base is opposite because it's opposite this angle, it's across from it. And this side is adjacent because it is next to the angle. So when solving a word problem, you can see we've already done my first 2 recommended steps. And if this is not on your note sheet, you can add this to your note sheet. 1, draw the triangle. 2, label the triangle with information given and requested and opposite, adjacent, hypotenuse. Okay, here we haven't labeled the hypotenuse because we don't want to overdo it. We don't want to start adding in a lot of extraneous information that we don't need. Here, we're given the angle, we're given the adjacent length, we're asked for the opposite length. If this is enough information to solve for x, to solve for the information that we need, we don't want to start loading a bunch of information, additional information on there, because then we're introducing the opportunity for error. Okay, so now that we have drawn the triangle and we have labeled the triangle, now we need to write the equation that we're going to solve. And the way that we're going to do that is we're going to look at the information that we're given and the information that's requested. And since this is trigonometry, we're going to match the ratio to the situation. So here we're asked for opposite, we're given adjacent. What are the two ratios that deal in opposite and adjacent? Tangent and cotangent. Which one of those is on our calculator? Tangent. So we're gonna use tangent. And we're gonna remind ourselves the equation. Tangent of theta is opposite over adjacent. But can we rewrite this with the information that we have and the information that we need? Yes, we can. So we can say tangent of 35 degrees equals x over 25. So we've just rewritten the definition that we know, but we've plugged in the information that we have and the information that we need. Now this is an equation that we can very easily solve for x. Right now we have x divided by 25. To get x alone, we just need to do the opposite operation, multiply by 25. So we're going to multiply both sides by 25. And so we get 25 tangent 35 equals x. Okay, now, is 35 degrees one of the usual suspects? No. It's not 30, it's not 60, it's not 45. I don't know what the tangent of 35 degrees is. But my calculator knows what the tangent of 35 degrees is. And are we allowed to use our calculators? Yes, we are. So, in order to solve this one then, we just type that into the calculator. First we check our mode. We check to see are we in degree mode? Yes, we are. And then we do 25 tan 35. Hit enter. 17.5 feet. Voila. The child is 17.5 feet from the maypole. So we draw the triangle, we label the triangle, then we match the trig ratio to the situation, and then we solve. So we drew the triangle, we labeled the triangle, including, importantly, the opposite and adjacent. Why did we need that? Because we need to know what trig ratio to match to the situation. Then we say, okay, this has to be tangent, plug in what we know and what we need, and then solve. So we did do some of this at the beginning of the quarter. Maybe we've gotten a little rusty on it. So this is just a refresher on how to solve a problem of this type. Next, I'm going to clear the board and we are going to talk about the